Water service installation. The water service is routed to the incoming side of an interior meter and the outgoing side of an exterior meter. The municipality or community typically installs the water meter and box or vault. A connection from a municipal water service to a distribution system requires a valve and possibly a pressure-reducing valve. Same trench with sewer. If a water service is installed in the same trench as a drain or sewer, backflow could occur. If the drain or sewer developed a leak, the surrounding soil could become contaminated with sewage. If the water service developed a leak and the water system was shut off, the sewage could backflow into the non-pressurized water service through the leaking area. To protect against backflow, codes regulate the installation of a water service in the same trench as drainage piping. When placing soil back in a trench, the soil must be compacted or tamped. Most codes dictate that a water service installed at the same elevation as a sewer must be separated from the sewer by at least 5 feet of undisturbed or compacted soil. Perpendicular installation. True perpendicular is a pipe that is installed at a right angle or 90 degrees from another pipe. Many codes require interpretation of intent as opposed to specific definitions of terms. A water service that crosses a sewer trench at any angle is considered perpendicular in this scenario, because the regulating code is concerned with the safety of the water supply system. To ensure that the water service pipe is protected against damage from possible excavation to access the sewer, most codes require that pipe crossing a sewer trench be installed in an oversized piece of pipe known as a sleeve. Water distribution installation. The layout of a water distribution system varies based on the job site and the fixtures being served. Water piping is typically installed after the drainage and vent piping because the water piping system consumes less space in walls and ceilings, and the code regulations are less strict. Once you know the main route, you can decide how the smaller branch will be connected or routed. The rough-in and termination of the water piping are based on the specific fixture. The sizing of a system depends on the quantity and type of fixtures being served. A codebook indicates the minimum size pipe that can be routed to each type of fixture. When all calculations are finished, you will determine the actual pipe size to install. There are 3 main segments of a water: the main, the branch main, and individual supply. An individual supply is a pipe serving one fixture. Sizing theory. Theory determining the available water of a certain pipe size based on volume and pressure plays a major role in pipe sizing. A water supply fixture unit, WSFU, is the term used to describe the end result of a flow calculation. The pipe size determines how much water is in a pipe, and the pressure determines how fast the water can be delivered to a fixture. Codebooks allocate a WSFU value of specific fixtures. Most residential fixtures have a hot and cold water supply, and the faucet type is often the determining factor of water flow. Codebooks will list the hot and cold values separately, but allow a deduction of the WSFU value when a fixture has hot and cold water supplied. Job site sizing. A plumber must know the minimum pipe size that can serve a specific fixture based on codes. Another factor is the type of connections to valves located beneath a fixture. Both a toilet and a sink use an isolation valve known as a stop. The most common stop connects half-inch, 5/8 OD, pipe to 3/8 OD tubing. The half-inch pipe stubs out the wall or through a floor, and the 3/8 portion of the stop is connected to the fixture with supply tubing. The size of the stop to be installed is often more important than the codes in determining the size of the rough-in water pipe. Some codes allow 2 fixtures, each with a half-inch or less individual supply pipe size requirement, to be served by a half-inch branch main. Other codes allow 3 fixtures on a half-inch pipe. Many companies install 3/4 pipe up the last branch connecting 2 different fixtures to eliminate any potential volume problems. Most dishwashers are provided water from the same isolation valve area as the kitchen sink, and would require the tubing to be more than 30 inches. The pipe size for a toilet and sink is reduced from half to 3/8 at the isolation stop below the fixture, which explains why the 30-inch maximum distance is important. Wall layout. The wall rough-in for a water distribution system is determined by the fixture type and the job site. There are standard dimensions for typical fixtures, but company preferences vary. A plumber makes sure that the piping that stubs out a wall accommodates the fixture being served. A sink installed in a countertop offers more flexibility as to where a pipe terminates than does a stub out serving an exposed fixture connection. Because water flows through the piping system under pressure, the piping can be routed in any position to accommodate specific job conditions. Drainage piping, on the other hand, must be installed with specific fittings and in certain positions to allow the water to flow by gravity. The water piping system is typically installed after the drainage and vent system because it has less critical installation requirements. Not all fixtures require a hot and cold water supply, nor do all of them require stub-out pipes. Toilets. A plumber installs the in-wall piping for a toilet based on the location of the center of the toilet, with the standard dimension being 6 inches to the left of the toilet center. The stub-out location is standard for most toilets. If a one-piece toilet is being installed, the plumber must use a rough-in sheet provided by the manufacturer. Two-piece toilets with a separate tank and bowl allow for a slight variation as to where the stub-out is installed. A company may want specific rough-in heights from a floor, but the stub-out location on the left side of a toilet is considered industry standard. A rough-in occurs before any flooring material is installed. If the floor is tiled, the plumber must install the water piping higher to accommodate the tile. The wood trim known as base molding is higher in many custom homes than spec homes. If the plumber installs the stub-out too low, the piping conflicts with the base molding. If the stub-out is too high, making the final connection to the toilet may be impossible. A water piping wall layout may be on a lower floor than the toilet if the water supply serving it is installed through the floor. This installation is rare in new construction but is often used in renovations. Lavatories. A lavatory installed in a countertop has different requirements from a pedestal lavatory. The area inside the sink base cabinet is not visible, so a plumber can install the stub-out without being exact. A pedestal sink has visible piping below the sink. A plumber must install the stub-outs at the same height and a specific distance apart from the center of the pedestal sink. The water stub-out is typically filtered with an 8-inch spread for a cabinet-type sink. The stub-out for a pedestal sink usually has a 4-inch or 6-inch spread, so the isolation stops, and flexible faucet tubing are more visually appealing. The maximum height for most lavatory water piping, regardless of its type, is 21 inches above the finished floor. As with many vertical dimensions, company preference and specific fixture types may vary. Bathtubs. Using a combination tub and shower (TNS) faucet does not change the sizing requirements for the individual fixture supply. The faucet and associated piping for a one-piece tub and shower unit as well as the unit itself are installed in the wall during the rough-in phase of construction. This lets a plumber know the installation requirements for a particular faucet. A manufacturer provides installation instructions indicating where the faucet is in relation to the finished wall. Many walls that surround a bathtub are tiled or have a solid surface such as marble. A plumber must read the instructions before installing a faucet in a wall during the rough-in phase to avoid access to the wall for corrective action during the trim-out phase. This figure illustrates water pipe routing through a floor serving a large capacity tub. Showers. A shower faucet is similar to a tub and shower faucet, but it does not have the tub spout connection. A shower faucet installation is the same as that of the tub and shower faucet. The shower head height is usually 6 feet 6 inches from the finished floor of the shower. The distance of the faucet above the floor varies depending on company preference, but generally ranges from 3 feet to 4 feet from the finished floor of the shower. For a tiled shower, a plumber must know the finished wall thickness from the wall studs. A faucet has a plastic protector and wall thickness gauge to protect the faucet finish and to indicate where to install the faucet based on various job site conditions. The center of the faucet is usually centered in the shower. One-piece shower units may have a dedicated area to install the faucet. Handicap showers have factory-installed grab bars, with the faucet placed in a dedicated area above them. Some showers have handheld spray units and multiple shower head features that dictate the placement of flow control devices and valves. The actual installation is based on job site conditions and manufacturer's instructions. Kitchen sinks. Water piping installation that serves a kitchen sink is similar to that in the countertop lavatory. The piping configuration under the sink depends on specific job site conditions and on whether a dishwasher is being installed. Most kitchen sinks are installed along an exterior wall and centered beneath a window. Floor penetrations can be used to route the water piping vertically into the cabinet if there is a crawl space or basement below the sink cabinet. The insulation requirements of exterior walls vary in different regions, but most plumbing codes dictate that the water piping must be installed on the interior side of the wall insulation. At least 1 inch of insulation must be installed over the pipe according to most plumbing codes. Drilling and notching. Drilling through wood boards can weaken them, and positioning or sizing a hole incorrectly can create an unsafe condition. The possibilities of snowfall, hurricanes, tornadoes, and earthquakes are main reasons for variances in drilling and notching codes. It is essential to know whether structural wooden boards are load-bearing to correctly determine the allowable sized holes that can be drilled. Notching is making a cut on the edge of a wooden board. The depth of the cut is strictly regulated and is determined by the area of the joist being notched. Holes and notches that place the outside diameter of a pipe close to the edge of a stud, joist, or plate must be protected against nails and screws. Most codes require that a nail plate, stud guard, be installed wherever a 1½ inch nail or screw could penetrate the piping. A nail plate is a 1/16 inch thick steel plate that is available in different lengths and widths. Piping installed horizontally through a wall stud requires only a 1½ inch wide nail plate, but pipes passing vertically through a top or bottom plate must be protected with a 4 inches wall plate. Some local codes specify the kinds of nail plates that can be used. This information is listed in a local code book. It is important for a plumber to understand how drilling and notching codes protect the inhabitants of a house. Plumbing and building inspectors focus on these areas in a job site walkthrough, and violations are taken very seriously. Exterior walls are load-bearing and are typically regulated like interior load-bearing walls. Some interior walls are classified as partition, are regulated differently, and with fewer restrictions than low. The location of a drilled hole or notched area is regulated to protect the structural integrity of a wall stud. A notch and a hole cannot be located in the same area, and a hole cannot protrude into a 5/8 inch protected area on either edge of a wall stud. Some codes state that 40% of a load-bearing stud and 60% of a non-load-bearing stud can be drilled. Other codes allow a load-bearing stud to be drilled 60% if the stud is double, but not more than 2 consecutive doubled studs can be drilled. Still, other codes state that a maximum of 25% of a load-bearing stud and 40% of a non-load-bearing stud can be notched. Table explains load-bearing and non-load-bearing 2x4 and 2x6 wall studs and the maximum allowable hole sizes. Joists. A joist is a horizontal structural support classified as either a floor joist or a ceiling joist. The joists that separate different levels of a house are floor joists, and ceiling joists are the structural boards of the highest ceiling in a house. The size of a joist depends on the design intent and the structural load of a particular area. Two common sizes are 2x8 and 2x10. But a 2x12 size is used for larger buildings or for greater span requirements. Because a joist has a different structural purpose from a wall stud, it also has different drilling and notching code regulations. Some codes do not allow any holes to be drilled in the middle 1/3 of a span. Other codes require a joist to be reinforced with exterior grade plywood if a large diameter hole is to be drilled through it. Some codes do not allow a hole to be drilled in a floor joist in the area that has a load-bearing wall directly above it. Thorough code knowledge is required before drilling and notching joists. A joist can be difficult and expensive to be replaced, and an inspector can demand that a company provide a certification from a structural engineer for a joist that has been altered. The defining terms of length, width, depth, and span are used when installing wood boards. A board used vertically to erect a wall is called a stud, and that same wood board used horizontally is called a joist. The dimension of a board known as the width for a wall stud is called the depth for a joist. The length of a wall stud is known as the span of a joist. A carpenter often notches the ends of a joist during the framing phase of construction. A plumber might also have to notch a joist to install piping that conflicts with the joist, but strict codes dictate the maximum depth of the notch. Some codes dictate that the end of a joist cannot be notched more than 25% of its depth. Other codes allow notching at the bottom and top of a joist as long as the notch does not remove more than 1/6 of the depth of the joist. Still, other codes do not allow any notching in the middle 1/3 of a joist. According to some codes, holes cannot be drilled in a 2 inches protected area around the top and bottom edges of a joist. The 2 inches protected area also typically includes the area where a joist contacts the load-bearing wall or other vertical support. Where holes are allowable in a joist, some codes dictate that a hole cannot consume more than 1/3 of the joist depth. This figure illustrates the protected areas of a joist pertaining to drilling holes. This table indicates the maximum allowable hole sizes. Hangers and supports. Supports are usually attached to wooden boards with nails and screws. Copper tubing uses copper-plated hangers and supports, and flexible tubing such as PEX uses plastic materials. Plastic pipe products such as CPVC and PVC are more rigid than flexible tubing and, if allowable by local codes, they can typically withstand metal supports without being damaged. A plumber often installs additional wood boards so that hangers and supports can be installed where desired or where dictated by codes. Maximum spacing between hangers and supports is also dictated by codes, and different materials have different spacing requirements. Pipe routes are often determined based on the most practical or productive method of installing the required number of supports. The location of piping can determine when support is needed. Water piping stub-outs require a support bracket or other adequate means of support to eliminate the possibility of damage to the piping when wallboard or cabinets are installed. Earthquake-prone regions are regulated by seismic codes and may require special methods and spacing allowances to support piping systems. A plumber must be knowledgeable about these specialized codes. Many manufacturers offer several hanger designs to accommodate plastic and metal pipe. A clevis type and an adjustable swivel ring type hanger are available, copper-plated for installing copper tubing and rubber-coated for installing plastic tubing. It is important to use the correct hanger to avoid damage to the pipe. Code dictates that copper pipe that is not insulated must be installed with a copper-plated hanger to prevent electrolysis corrosion. Position of the pipe, whether it is horizontal or vertical, is also a deciding factor in the type of hanger selected. Compounds and sealants. A compound used for threaded connections, known as pipe dope, is applied only to the external portion of a male thread before screwing it into a compatible female threaded fitting. A sealant known as Teflon tape that provides the same watertight connection as pipe dope is also used for threaded connections. Flux is a paste used for soldering copper tube. It is placed in a fitting socket and on the external portion of the tube, so the solder can flow into the fitting socket. Solder is used to weld a copper fitting connection. Its melting point varies based on the percentage of alloys used in the manufacturing process. Soft soldering for welding is sold in roll form. Another welding process known as brazing or silver soldering is used for copper connections. It employs a stick, rod, form solder that has a higher silver content than most types of soft solder. Brazing is performed without flux and at higher temperatures. Soft copper tubing can be connected to another copper tube or to a piece of equipment with a flared connection. A flaring tool is used to fold or spread copper tubing to mate with a compatible manufactured flared fitting. The fitting design and flaring tool have compatible flare angles to ensure that a proper flare is created. Plastic piping uses a solvent welding process that requires a cleaner, glue, and primer to create a permanent connection. Each of these basic connections is unique. A plumber can connect different types of piping with threaded connections. Pipe dope is used extensively with metal threads, and Teflon tape is used for both plastic and metal threads. Soldering. Soldering is a welding process commonly known as soft soldering. It is designated soft soldering to indicate that it requires flux and a roll of solder. A wire brush is used to clean the inside of a fitting socket, and sand cloth is used to clean a pipe. Brazing. The brazing process requires extreme heat but does not require the use of flux. Brazing is also known as silver soldering. The solder is sold in either flat or round rods, often called sticks. Silver solder has various percentages of actual silver. 2%, 5%, and 15% are the most common. Residential construction uses small diameter pipe, and a small handheld torch can provide adequate heat, but piping larger than 1 inch requires a larger torch. The goal is to complete a silver solder joint that has a uniform cap, bead, of solder along the ridge of the fitting. Flaring. Flaring copper is the process of folding or spreading the pipe end with a flaring tool. Soft copper is used to make a flared pipe end that is mated with a compatible threaded flare fitting and flare nut to complete a connection. A flare nut, which is typically sold separately from the fitting, secures the pipe to the fitting. A threaded flare connection does not require pipe dope or Teflon tape and is considered a ground joint because it is a metal-to-metal connection. Buried copper water piping, such as a water service from a water meter and gas connections to equipment, uses flared connections. The greatest benefit of a flared connection is that it can be disturbed or moved under pressure without leaking, and the connection can be loosened with wrenches. A solder joint is a permanent connection that requires a union to be installed to access the piping system, but a flare nut serves as a union-type connection. Some codes dictate that PEX cannot be connected directly to a water heater, so it is usually converted to copper. A PEX expanding process utilizes a memory ring instead of a crimp ring but is still connected to copper using a specific adapter. Manifold systems. In a manifold system, the water service piping enters the house to a designated area where the manifold is installed. All piping serving fixtures originate from that location. A manifold system is often referred to as a parallel system. Hot and cold water manifolds are installed separately. Individual pipes are routed from a manifold to a fixture when installed as part of a parallel manifold water distribution system. Testing. Testing a water distribution system is mandatory. The pressure applied is dictated by code. Most cold weather regions use air tests during colder months, so the piping system will not freeze. Most codes dictate the duration of a test, and, because an inspector is usually not required to remain on a residential job site very long, most tests are only 15 to 20 minutes long.